Hello there, this is a geometry video. It is chapter 6, section 5, and today we are continuing our discussion over parallelograms with rhombi and squares. Rhombi obviously being plural for a rhombus. So we're going to start with rhombus, and a rhombus is a parallelogram with all four sides congruent. So we know that all of the properties that apply to parallelograms also apply to a rhombus, but also in addition to that, for example, we know that in all parallelograms opposite sides are congruent, but in this case all four sides are congruent. We know that opposite angles are congruent, that all of the consecutive interior angles add up to 180. All those properties from the previous lessons still apply to a rhombus, but in addition to that, we have some here that I want to talk about as well. And again, these are some theorems, and I just kind of condensed them into the same screenshot so you wouldn't have to write as much. But basically, we have two theorems. If a parallelogram is a rhombus, then theorem number one, or it's not number one, but the first theorem that we have is diagonals are perpendicular. So we already knew before that for any parallelogram, the diagonals bisect each other. But this time, not only do they bisect each other, they're perpendicular. That's unique to a rhombus. Number two, each diagonal bisects a pair of opposite angles. So if I were to draw in the diagonals here for this diagram, then we would get that that segment HF and GJ would be perpendicular. So we have all these little perpendicular angles going on. That's the first part. The second part is that each diagonal bisects a pair of opposite angles. So the FH diagonal bisects the opposite angles. So this angle is now bisected, this angle is now bisected, and vice versa here as well. Okay? So that's what we have for a rhombus. So in our example, it says the diagonals of rhombus FGHJ intersect at K. Use the given information to find each measure or value. So it says here in part A, if the measurement of angle FJH, so let's see here, FJH, where are you? FJH, this angle here, the entire angle, is 82. What is the angle of KHJ? KHJ, okay, so here's what we know. We know that this is 90 because they're perpendicular. We know that the measurement of angle FJH combined is 82. But because this diagonal bisects the angle, if this entire angle is 82, then we can divide that by 2 and get 41. So that little angle right there is 41. And they want KHJ, which is this angle right here. This is the one in question. So we would have to take 180. Well, we know that 90 plus the 41 plus the measurement of angle KHJ should equal 180. If we take the 90 and the 41 away from the 180, then we get our answer. The measurement of angle KHJ is going to equal 49. And that is how the cookie crumbles for that one. All right? So now we want to kind of erase this information because it's not going to pertain to everything. Obviously, they're still going to be perpendicular, but our next example says if GH, so where's GH? GH is this segment here, equals x plus 9. And JH, here's JH, equals 5x minus 2. Find x. So again, this is a rhombus, and so because it's a rhombus, all of the four sides of the rhombus should be congruent. So that means that I can say that x plus 9 should equal 5x minus 2. So I solve for x, subtract x here, add 2 there. 5x minus x is 4x. 9 plus 2 is 11. Divide both sides by 4. I don't know why they couldn't just give us a nice even round number, but they don't like us. So 11 divided by 4 is 2.75. And that is our x value. So not really complicated, but there you go. So now I want you to do it yourself, number 1. Now remember, this is referring to the rhombus in the previous example, so it's the same diagram but different information. Okay, now we're going to move on to squares. Like SpongeBob Squaresy Pants. That's how my niece says it, so I'm sorry. But anyway, square. A square is also a parallelogram. And like a rhombus, it has 4 congruent sides. But also like a rectangle, it has 4 right angles. So basically, if you put a rectangle and a rhombus together, you might get a square, all right? So we have our little diagram over here, but also wanted to give you some theorems here. So again, a square is 4 congruent sides, 4 right angles. I think most of us are pretty familiar with squares. But here we have basically our converses. So what I've done here is these are conditions. Like in the previous example, we knew that it was a rhombus, and therefore certain conditions applied. So now we're going backwards. We don't know that it's a rhombus. We're trying to prove that it's a rhombus. So what conditions have to be in place for it to be a rhombus and a square? And that's what we have here. So all of these in the same color are referring to a rhombus. And then our last one here is referring to a square. And these two are asterisked, because they are converses of the 2 theorems that we just saw previously about rhombuses. Okay, so basically it says, in this case, instead of saying that it's a rhombus first, we conclude that it's a rhombus. So you can see it there, and then the parallelogram is a rhombus. So how do we know if you're a rhombus? Well, if, converse of theorem 1, if the diagonal is perpendicular, then it's a rhombus. If one diagonal of the parallelogram bisects a pair of opposite angles, then it's a rhombus. And then our third one is not a converse, but it is one of the theorems that we use to prove that it's a rhombus. So if one pair of consecutive sides is congruent, then it's a rhombus. Consecutive sides. Now for that, I think I probably should give you a little diagram. So let's just draw one, a really quickly one here. Let's suppose that this is a rhombus, so these are all congruent. All right. What it's actually saying, sorry, I do that prematurely. We don't know that it's a rhombus. So let's say we have a figure, kind of like this, and we don't know if it's a rhombus, but we know that 2 consecutive sides are congruent. That's what it's talking about, consecutive sides. Basically means a side that's next to each other. So either this side and that side, this side and that side, this side and that side, this side and that side. Consecutive means one after the other. So we're not talking about opposite sides, we're talking about consecutive sides. So if you have one pair of consecutive sides congruent, then it's a rhombus. So those are our 3 conditions to determine whether or not the figure is a rhombus. Our last one refers to a square. If a quadrilateral is both a rectangle, meaning it has the 4 right angles, and a rhombus because it has 4 congruent sides, then it is a square. So you can see there how I was talking about earlier, like if you had a rectangle and a rhombus and they had a baby, maybe it'd be a square. Okay. So anyway, maybe I have maybe other brain, I don't know. But here we go. In example 2, they want us to use some of those theorems to basically write a proof. And I've already written the proof out in the interest of time, but I want to kind of walk you through it as well before you have to do one on your own. So it says, given that JKLM is a parallelogram, so we know that it's a parallelogram, so all the properties that apply to parallelograms apply to this diagram. And also they're telling us that JKL, so if you follow the here, JKL, this top triangle here, is isosceles. Okay? If it's isosceles, that means that these sides are congruent. Okay, and so what you'll see here in my proof is that the first thing I start with is triangle JKL is isosceles. And because it's isosceles, and that was given, because it's isosceles, I put that KL is congruent to JK, and that's by definition of an isosceles triangle. And if you mark those are consecutive sides. So you'll see here I put KL and JK are consecutive sides of a parallelogram, and that's given from the diagram. You can see that from the diagram. And because they're consecutive sides, we just saw in our previous slide, that's one of the ways that we can tell that it's going to be a rhombus. So my last step is, therefore, JKLM is a rhombus. And the reason is actually technically Theorem 6.19, but I wrote it out here because most of the time we don't want to put numbers as our reasons because every book is different and has it labeled slightly differently. So it's better for you to actually write it out. So what I put is one pair of consecutive sides congruent implies rhombus. Okay? So I should probably not put implies parallelogram, I should put implies rhombus. So I should probably write implies rhombus. Okay, but I did abbreviate consecutive sides congruent. The little arrow means implies, so it's like an if-then situation. So if one pair of consecutive sides congruent, then rhombus, and then my Helmholtz. All right, so that's my proof. It's a very short proof, and yours will be too. So this is do-it-yourself number 2. Write a 2-column proof, and they have some information for you there, and then we'll discuss that in class if you didn't quite figure it out. Then we're going to skip example 3, and we're going to go straight to example 4. And in example 4, it's asking us to determine whether or not this parallelogram with these particular vertices is a rhombus, a rectangle, or a square. And sometimes you can be more than one thing. For example, a square can technically be considered a rectangle because a rectangle, the only definition for a rectangle is that it has to have 4 right angles, which a square has, and it has to have opposite sides congruent, which a square has. So technically a square could be considered a rectangle, but a rectangle can't be considered a square. See, so there are ways that you can kind of overlap. So it says to list all that apply and explain. So first thing we're going to do is we're going to start off by plotting our points. So J is -7, -2, so here's -7 and -2 is down here somewhere. Put that little guy there. Then we have 0, 4, so x is 0, y is 4. We have 9, 2, so here's 9, and 2 is up here. And then we have 2, -4 down there. And we're going to connect our points here. Hopefully my ruler is long enough to connect all of these. It's quite the large parallelogram here. And in order for us to know what's going on here, we're going to start by using the distance formula. So let me just read you our plan here. When we look at the diagram, we can pretty much tell that it doesn't have any right angles. So we know that it's not going to be a square or a rectangle, but it could be a rhombus. All right, so that's basically because you can see here that these are not going to be 90-degree angles. But we know that if diagonals are, so we can pretty much rule out that it's not going to be a rectangle, it's not going to be a square. But if we want to confirm that it's going to be a rhombus, so I think the easiest way here, there's different ways of doing this, but I'm trying to find the easiest way. For example, you could find the distance of all the 4 sides. You could find the slope of all 4 sides and then try to confirm any of the right angle situations. But I think that the easiest way for us to go about this problem is to actually deal with diagonals. So what we want to do is find the length of the diagonals. So let's label my points first and foremost. I don't know what I'm doing here. Let's see. We got J's over here. We got 0, 4, this is K. 9, 2 is L. And then we had M. So what we're going to do is the first diagonal is going to be JL. See, I said JL, but I wrote JK. So JL, and our second diagonal is going to be MK. Okay, now let me see if I can, maybe I want to write MK down here actually. All right, so let me tell you what's going to go on here. Okay, we're going to find the distance of the diagonals, because if the diagonals of the parallelogram are congruent, then it's a rectangle. If they're perpendicular, then it's a rhombus. If they're both congruent and perpendicular, then it's going to be a rectangle, a rhombus, and a square. So we can actually figure out everything we need to know by just using the distance formula for now. Okay, so we have to figure out if the diagonals are congruent, and we have to figure out if the diagonals are perpendicular. So instead of doing like all this extra work for all four sides, we really only have to consider the diagonal sides. So I'm going to start with the distance formula for JL. So with JL, here's -7, -2, and L is 9, 2. Remember how we do that? We want to take the difference in the x value. So the x value of L is 9, and the x value of J is -7. And then we want the difference in the y values for JL. So we're going to go 2 minus -2. So that's what we get right there. Okay? So remember that. I even wrote that wrong. I am so sorry. Well, it's not completely wrong. I need to put my parentheses. I'm missing a set of parentheses. Let's put them right here. Squared. And then this one's correct. All right, so basically what I need to do is here 9 minus -7, which is 9 plus 7. And 9 plus 7 is 16. And then we're going to square 16. Then we have 2 minus negative, which is plus. So 2 plus 2 is 4, and square that. So 16 squared is 256. And then 4 squared is 16. 256 plus 16 gives us 272. So we get the square root of 272. Now we're going to try MK. Do the same thing. With MK, we're going to go, where's M? Okay, so the x-coordinate of M is 2. And the x-coordinate of K is 0. And then the y-coordinate of M is -4. And the y-coordinate of K is 4. So we're going to get 2 minus 0, which is 2 squared. -4 minus 4, which is -8 squared. So we're going to get 64 plus 4. Which is the square root of 68. And that is not the same thing as the square root of 272. And so basically what we've just discovered is that since the diagonals are not the same, they're not congruent, then that means that it cannot be a rectangle. And if it can't be a rectangle, it also can't be a square. So the only other thing we can do now is try to confirm that it's a rhombus. And so to confirm that it's a rhombus, the diagonal should at least be perpendicular. So now again, I still want to use point JL, but I want to find the slope of JL and the slope of MK to confirm that they're actually perpendicular. So the slope formula is the change in y. So again, I'm going to J and L. So the change in y coordinate is -2 for J. So y2 minus, and then L is 2 over x2, -7 minus 9. Okay, so I'm trying to find the slope now of JL. So I'm going to take y2, -2, and subtract y1, which is the y-coordinate of L, which is 2. And on the bottom, I'm going to take x2, which is -7, and subtract the y-coordinate of, the x-coordinate of L, which is 9. So -2 minus 2 is -4. -7 minus 9 is -16. So negative divided by negative is a positive, and 4 goes into 4 once, and 4 goes into 16. So we get 1/4. the slope of JL is 1/4. So now we're going to find the slope of MK, and hopefully it'll be -4. And if it is, they will be perpendicular, and we will have determined, proven, if you will, that it is in fact a rhombus, which is what we speculate right now. So MK. So here's M. Y coordinate of M is -4. Subtract the y coordinate of K, which is also 4. And then we want to go back to M and have the x coordinate 2 and subtract the x coordinate of K, which is 0. So we get -4 minus 4, which is -8. And 2 minus 0 is 2. And sure enough, -8 divided by 2 is in fact -4. And since these are negative reciprocals of each other, then they are perpendicular. So JL is perpendicular to MK. And therefore, this figure is a rhombus. It is not a rectangle, not a square, because the diagonals were not congruent. So now we're going to have you do a similar thing with this do-it-yourself question. And once you have completed this example, then you will have completed your notes for this lesson. And I will see you in class, and thank you for watching.